just now. Okay, let's proceed. Okay, dimethyl nitrosamine is a carcinogenic substance which is formed in food, beverages, or gastric juices. Okay, first question. Calculate the molar mass of dimethyl nitrosamine. So total up all the atomic masses, okay, for all the element present in the substance, in the compound. Okay, all right, so this is the unit. Okay, very good. So we have all the units there. Let's make it bigger. Okay, so we have all the units that the units, okay, and then we end up with the gram per mole. Okay, so it is 74 gram per mole. So the unit carries, okay, till the end. So that's why we ended up with the gram per mole. Okay, moving on. Calculate the moles of 2.5 gram of dimethyl nitrosamine. Okay, so here Shahira is using the conventional way, okay, conventional method in order to calculate for the mole. Okay, all right, so this gram will be cancelled out and then we have mole. Alternative to that, you can also use dimensional analysis. So use whatever information given, the value given here is in gram. So it should be 2.5 gram, okay, of dimethyl nitrosamine. After all, we are only dealing with one substance, okay. So we may skip the the entities, okay, the name of the substance, or if you feel like you want to include, that is even better, okay, because we want to know 2.5 gram of what. Okay, dia mesti ada entities itu, the substance, the name of the substance. Okay, let's just make it proper lah. Okay, so CH3 2N2O. So this is the entities. All right, multiply, and then here we have. So here we should have the unit of gram. Okay, at the bottom here, gram CH3 2N2O. Okay, it should be the same. So what could be used as the denominator, the value for the denominator in gram? Okay, as of now, we only have the molar mass. Okay, molar mass has the unit in gram. So we have calculated just now the mass of dimethyl nitrosamine, which is 74. Okay, and then at the top as denominator, so what should we put here?
1 mole.
What's the relationship?
1 mole.
1 mole.
Okay, so that is the relationship. Dia bukan suka-suka je kita letak kat atas tu, kat bawah, atas dengan bawah tu. Dia mesti ada relationship between them. So it is 1 mole of dimethyl nitrosamine. Okay. Alright, so we can cancel out this and this because they have the same unit, and tekan calculator, we will get the final answer and the unit as well. Kita carries till the end, kita dapat CH3 2N2O. Okay, alright. So if you were to use, you have decided to use conventional method, then saya tak boleh paksa lah kan. I cannot force you. But please make sure that you do it properly. Okay, include the unit. Please guys, saya dah cakap banyak kali. Okay, include the unit. Okay, if not, please learn how to use dimensional analysis. But because dimensional analysis, we need to have the unit. Because from the unit, it allows us to manipulate, okay, which unit should be placed at the bottom and which unit should be placed at the top. Without the unit, dia macam tak lengkap for the dimensional analysis tau. Okay, that's why we have to use the, we need to have the unit. But for the formula, okay, we it's not necessary for us to include the unit. That's the thing. Bila you rasa benda tu not necessary, that's why you do not include the unit. Sepatutnya it should have its own unit. Okay, alright. Determine the number of nitrogen atom present in 1.0 times 10 to the power of 16 molecule of dimethyl nitrosamine. Okay, so the question is asking for number of nitrogen atom present in this amount of molecule ataupun this number of molecule. Okay, alright. So this is molecules of dimethyl nitrosamine, and this is the question is asking for nitrogen atom. Okay, alright. So what do we have? What relationship that we have for these two? Okay, dimethyl nitrosamine just apa nama tu dia punya formula just now is CH3 then 2 and 2. Okay, from the formula itself, we know that in one molecule, okay, I'm talking about one molecule, okay, in one molecule of nitrogen, in one molecule of dimethyl nitrosamine, there are two nitrogen atoms, see, there are two nitrogen atoms in it. So by using that relationship, okay, we could use it as our conversion factor for the calculation. Okay, alright. So for a start, okay, kalau yang ni Syairah ni dia guna apa nama tu dimensional analysis pula. Okay, so for a start, okay, let's have whatever information given from the question as our starting point. So just rewrite, okay, and then times and then conversion factor. Okay, so we should have the numerator and denominator. Okay, so here we have molecules of dinitrosamine. So here should be the same unit as here. It should be the same unit. Okay, alright. So we have molecules there. So what relationship so far yang kita dah belajar that has molecule as the final unit is Avogadro's number, kan? Itu this unit tells us, it gives us hint sebenarnya. Okay, on what to be placed as the denominator and nominator. So it helps a lot lah. Okay, from the unit that we have here, okay, we just transfer the unit here and then we determine what are the relationship that is possible. Dia banyak je possibility, tapi that's why saya cakap every time you need to know what you want. Okay, you need to know what you want. Can be kalau you dah advanced sikit, you have here molecules, okay, Avogadro's number, and then later on you may have apa nama tu molar mass. Okay, boleh letak molar mass dekat situ sebab we know that molar mass is for 1 mole and 1 mole is also equal to Avogadro's number. That one if you dah advanced. Okay, as of now, let's just stick to apa nama step by step punya process for dimensional analysis. Okay, alright. So when we have this Avogadro's number, then at the top should be 1 mole of N2 what do you call this, dinitrosamine, dimethyl nitrosamine. Okay, alright. So this one will be cancelled out. Good. Next. So we have here 1 mole of dimethyl nitrosamine, kan? So we carry the unit further, okay, for our next conversion factor. So we rewrite the unit at the bottom here. So it is mole of dimethyl nitrosamine. Okay, so here is the part where you introduce the nitrogen atom. So as you can see, okay, for this part and also this part, okay, both only involve dimethyl nitrosamine, maksudnya dalam bentuk molekul. Okay, so this is the part where we introduce the nitrogen atoms. Okay, where we introduce the nitrogen atom. Sometimes student dia letak dekat sini Avogadro's number ataupun molar mass. Dia letak dekat sini. Is it wrong? No, it's not wrong. Betul apa dia buat, tapi you are not answering the question. The relationship is correct, but you are not again answering the question. The question is asking for nitrogen atom, not the mass, not the what else, apa nama tu, Avogadro's number. Okay, bukan. Nanti you akan cancel out, you maksudnya dia apa nama tu, tak ada purpose pun kalau you keep on using the same conversion factor. Okay, so that's why you need to know what need to be put and what do you want, okay, what is given to you and what will be the final answer, the final unit. Okay, so kita nak nitrogen atom. Okay, kita nak nitrogen atom tadi dekat sini kan. Okay, cuba kita tengok ya. Dia nak number of nitrogen atom. Okay, ni agak panjang jalan dia tapi boleh. Okay, you still get the same answer. Okay, so 1 mole. So here kita nak relate 2 mole of nitrogen atom. Okay, so 1 mole of dimethyl nitrous amine. That means the number of nitrogen atom should be 2 mole of nitrogen atom. Okay, alright, so here is the part where nitrogen has been introduced. Alright, so next moving on, kita carry further. Kalau based on Syahira lah, Syahira's answer here. 1 mole, so bawah ni should be mole of nitrogen atom. Okay, alright, so dekat bawah ni 1 mole of nitrogen atom, dekat atas should be number Avogadro's number. Okay, alright, so that's why we end up with this atom nitrogen atoms. That's why we end up with that. Okay, okay, alternative to this. Okay, it is a little bit shorter than what Syahira did here. Okay, alright, so let's just try out kat sini So we have the information given 1.0 times 10 to the power of 16 molecule of dimethyl nitrous amine. Okay, so this is what is given to us. This is already in molecule, guys. This is already in molecule form. Okay, all right. So we can introduce the nitrogen atom, number of nitrogen atom here. Okay, so like I said just now, what is the relationship that we have for molecule? Okay, we can have the number Avogadro's macam yang Syahira did. Alternatively, we can also have the 1 molecule of dimethyl nitrous amine has 2 nitrogen atom. Betul tak? That relationship. So for okay, kita carry the unit first. 1 molecule. This is the same as what we have here. Molecule CH3, 2 and 2O. Okay, for 1 molecule of dimethyl nitrous amine, there are 2 nitrogen atoms. Okay, so kita cancel out here and here, so we will end up with the same answer. Dia darab 2 juga sebenarnya. Sebab you guys nampak tak dekat sini? Sini sebenarnya dia akan cancel out with this Avogadro's number. The value, okay? The value will be cancel out sebenarnya. So sebenarnya you tinggal 2 ni sahaja. So itu maksudnya kalau in short, we can use this as your alternative lah to this one. Okay, we are not, for this second method, second approach, we do not use the Avogadro's number. Okay, we can use the molecule itself. But regardless, salah ke? Tak salah yang atas ni, betul. Tapi dia panjang sikit lah. Sebab practice bila you beginner baru practice, you can tend to, you akan follow based on the unit lah. Okay, later on when you get used to it, you akan somehow dia akan develop from there. Okay, alright. Okay, good. Okay, so that will be your final answer. Next, D, calculate the mass in gram of 1 molecule of dimethyl nitrous amine. Okay, so the mass in gram of 1 molecule of dimethyl nitrous amine. Dia nak for 1 molecule, what will be the mass of it? Okay, alright. So this is 1 molecule. Kalau based on dimensional analysis, so this is the information. Okay, so this is the information. Sama like this one in C. So this is the value given kan. Okay, for D, the value given is 1 molecule. Cuma dia tak write in numbers, in value. Okay, instead dia write in words. So nampak macam tak ada value pun bagi. Ni value lah ni 1 ni. Okay, alright. So based on Syahira, okay, Syahira tukar pula. Ini dah lain pula. Kejap ada dimensional analysis, kejap ada apa nama tu conventional. So based on Syahira, so 1 divided by Avogadro's number. Okay, so this one we will have the mole for 1 molecule. Okay, alright. So to find the mass of for 1 molecule, Syahira's multiply with the molar mass. So this one mole will be cancelled out and we will end up with the gram. Okay, so that will be one of the way to answer this question, or if you are using dimensional analysis again, okay, let's start with 1 molecule. Okay, 1 molecule, CH3, 2N2O. Okay. Yep, this one. Okay. All right. Remember, what we want is the mass for 1 molecule of this substance. Okay. All right. So we have molecule there. So we could use the Avogadro's number. So molecule N2O. Okay. All right. So we have Avogadro's number 6023 times 10 power of 23 to 2. Okay. So here up here should be 1 mole of CH3 2N2O. Okay, so this is only in mole. Okay, the unit is still in mole. So what we want is the mass, kan? Okay, carry further. So here is mole, kan? So below here should be mole. Alright, so again kita nak mass, kan? So this is the part where we introduce the mass ataupun the molar mass lah. The mass for 1 mole. So it should be 74 gram. Okay, so 1 mole of dimethyl nitrosamine, the mass is 74 gram. Okay, alright, so cancel out the unit and tekan calculator, you will have the same answer by using dimensional analysis. Okay, right. Next question. Let's have Irfan. Checkpoint 11 done. Next will be checkpoint 12. Okay. Carbon dioxide gas is obtained from the fermentation of glucose. If 20 liters of carbon dioxide at STP are collected, calculate the number of oxygen atoms present in this gas. Okay, all right. So what we have here is the carbon dioxide. Okay, so the given value is in volume, which is in liter. But the question is asking for oxygen atom. So given the information is in CO2 form, but the question is asking for oxygen atoms. What will be the number of oxygen atom present in CO2? And to be specific, in 20 liter of carbon dioxide. Okay, so ini pun dah boleh. We can use the relationship of 1 mole of CO2 is equal will have 2 mole of oxygen atom. Okay, if you are using mole. Kalau molecule, that means 1 molecule of CO2 has 2 oxygen atom. Okay, all right. So it is also mentioned the condition at the condition of this fermentation, okay, which is at STP, right? What is the temperature at STP?
0 Celsius.
0 degrees Celsius. And how about the pressure at STP?
1.
1.
Okay, so at STP, what is the volume for gas substance at STP? what will be the volume for gas substance at STP for 1 mole, okay? For 1 mole.
22.4 liter.
Yes. Okay, thank you. Okay, don't get confused with the RTP. So the RTP will have the volume for 1 mole. Okay, dia punya information is at STP. Okay, for 1 mole. For 1 mole of gas. For 1 mole of gas, the volume is equal to 22.4 liter. Okay, or from the unit. Kalau kita nak change to unit, so this is what we call relationship. And we can also have the unit as this, 22.4 liter per mole. Okay, so this unit carries the same understanding ataupun dia punya meaning dia tu, definition dia tu, okay, relationship dia as this. So that means for 1 mole, the volume for 1 mole of gas substance, the volume is equal to 22.4 liter. Okay, alright. So Nisi mencari. Okay, good. Irfan is using the apa nama tu, what we call this, the dimensional analysis. Okay, so let's start with the information given from the question. So we have the 20 liter carbon dioxide gas molecule. Okay, alright. So liter kita carry lah kat bawah ni, liter carbon dioxide. So what else could be put here? It should be 22.4 liter. So if we have this 22.4 liter, that means up here should be 1 mole. Okay, alright. So if we have 1 mole there, that means here should be mole. Okay, just be apa nama tu, please include the entities. Okay, the name of the entities. Sebab we have 2 entities dekat sini. So we have CO2 and oxygen atom. Okay, so please specify your entities. Kalau dimethyl nitrous amine just now, okay, for mole for example tadi kan. Okay, if we are calculating for the mole, okay, we may not include the entities sebab we are talking ataupun we are calculating for that particular entities sahaja. We do not involve any oxygen ataupun dia punya elements in the ataupun dia punya atoms in the what we call that, in the substance. Okay, tapi for this calculation you have carbon dioxide and you have oxygen atom dekat situ. Kalau kat sini you are talking about what? You're talking about let me see. Okay, this is 1 mole. This is atom. Macam mana atom pula ni? Okay, this is 1 mole of carbon dioxide. Okay, this part is important. Why this part is why is this part important? Okay, it is because we want to convert the liter into mole. Okay, this conversion factor D is necessary because we want to convert the liter into mole. And then this part is necessary because kita nak tahu the number of what we call that, number of molecule. Sebab ni masih CO2. Okay, so ini masih CO2. Kalau based on Irfan buat ni, all of this, okay, the entities used is CO2. Ni campur ni. Okay, so kalau kat sini 1 mole of CO2, here is 1 mole of CO2. So by right, kat atas ni should be apa guys? What's the unit up here? Dia ada dia buat darab 2 ni dekat bawah. Okay, so up here, what should be the unit? Betul ke atom ni?
Molekul.
Ya, apa molekul apa?
Oksigen.
Oksigen. Macam mana boleh datang oksigen ni?
Carbon dioxide.
Yes, it should be carbon dioxide molecule. Because you are talking about 1 mole of CO2. Okay, belum lagi introduce the oxygen. Okay, alright. So it should be 1 mole of CO2 is equal to Avogadro's number of CO2 molecule. Mana boleh nak kata oksigen lagi? Belum lagi. Kita baru nak maksudnya kita kalau based on Irfan lah, dia tukar kepada molekul dulu. Okay, dia tukar kepada molekul. So this is CO2 molecule. Okay, alright. So ni bukan atom. Ini maksudnya konsep lemah ni. Tahu Avogadro's number, tahu ni. Tapi when you have to connect them, itu selalunya student dia tak tahu nak place atom ke, molekul ke apa. Okay? So here we should have the molecule of CO2. Okay? Alright. And then later dekat sini, dia boleh masuk balik pula conventional pula kat sini by using this relationship, okay, 1 mole of, so we are talking about molecule kan, sini kita bercakap pasal molecule. So 1 molecule of carbon dioxide, okay, has 2 oxygen atom. Okay, that's why lah dia darab 2 ni dengan value ni. Okay, kalau lah if we are using the dimensional analysis throughout sampai the end, okay, alright. So katakanlah here, okay, look at here dekat sini, kalau saya proceed further, there is one conversion factor that is needed, which is, saya tambah lagi okay, katakanlah kita delete dulu ni. Okay, ini yang kalau with respect to this one, this should be not, it should not be atom, it should be molecule CO2. Okay, kalau saya add in one more conversion factor, so here we should have the same unit, okay, CO2 molecule, that will be the unit. Okay, alright. Takkanlah nak letak Avogadro's number lagi, betul tak? So here is the part where we introduce the oxygen. Remember soalan apa? Soalan nak the number of oxygen. So we have the molecule already, right? So it should be in one molecule, in one CO2 molecule ataupun one molecule of CO2, we have 2 oxygen atom. Jangan pergi letak O2 pula, oxygen gas. O2 means oxygen gas. Okay, O2 means oxygen gas. It is understood that if it is in the form of O2, that means the phase ataupun the state will be gas. Okay, alright. So you are talking about O ni O ni saja ni. Ni O atom. We are talking about oxygen atom. So we can cancel out this CO2 molecule with this CO2 molecule. Tekan calculator, okay, from the beginning till the end, darab 2, and then you will end up with the same unit. Okay? Alright. Ni dah okay dah. Cuma kat sini tak erti kan nak guna apa kan. Dia dekat conversion factor tu, student most of the time students have a problem dekat the conversion factor. Okay, ini yang nak kena practice. Sometimes they got confused. Okay, nak guna ni ke, nak guna Avogadro's ke, nak guna molar mass ke. Okay, if that's the case, that means you kena tahu what is been given to you and what the question want. And then what are the relationship that we have so far. Okay, so if you have that one, okay, what you need to do is to practice more. That's all, and then you'll be good. Okay, so don't get frustrated with dimensional analysis. You are a beginner, so kita boleh expect lah style beginner lah. Okay, tapi jangan give up. Don't give up. Try again. Alright. Okay, maybe we can have. So we are 11. Okay, one more, and then we go. We have S20, okay? Alright, so let's have Shasha. Ke dah habis lah tadi? Dah habis kot soalan. Alamak, ada one more. The calculate the mass in gram, dah kan? Tadi dah. Yeah, we have discussed that just now. Is it? I don't think so. Calculate the... Not yet. Ini yang mana? This one. Aduh, madam. Jangan melabah, madam. Okay, so we next will be checkpoint 13. Okay, question 1. So both of the question involve empirical formula. Okay, alright. So methyl salicylate has a mass percent composition as given for carbon, oxygen, and hydrogen. So the mass of one molecule of the compound is given here. So this is the relationship that we have for one molecule. Okay, the mass is equal to this value. So this could be our conversion factor. Okay, so this is what we have so far. Okay, calculate for the empirical and then go for molecular formula. Okay, for the empirical dia basically sama je. Okay, saya just nak highlight here. Please be careful on the ratio, okay, the value of the ratio. Okay, so do not just simply round off atau just simply round off to the closest whole number. Okay, you have to multiply with a factor. You can only round off to the closest whole number if the different apa dia punya term dia tu dia punya tu adalah within 0.1. Okay, this is not 0.1. Dia punya decimal places tu not 0.1. So we cannot simply round off the ratio to the closest whole number. Okay, please do not do that. Okay, alright. So we need a factor. Kita perlukan factor that when we multiply this ratio, this value ni, okay, kita akan dapat the closest whole number. Okay, alright. So the best is 3. We need to multiply with 3. Okay, so multiply everything with 3. So this should be multiplied with 3, this one also with 3, and these two with 3. Do not forget any of them. Okay, alright, so multiply, so that will be your empirical formulas. Like I said in our previous lecture, do not leave your empirical formula as this. You have to rewrite. This would be your final answer. Without this, okay, your final answer for empirical formula, okay, will be deducted. Okay, alright, okay. Then we want to find the molecular formula kan. So the keyword for molecular formula ataupun formula or the hint to find the the molecular formula is you need to have the N. You need to find the value of N first. Okay, so the formula for N is molar mass of compound divided by molar mass of the empirical formula. So we have the empirical formula already just now. We can calculate for the molar mass. Okay, all right. So now the problem is to find the molar mass of the compound. Okay, that is why the information is given just now. Cuma dia tak bagi direct. Dia nak, biasalah, dia nak menyusahkan hidup kita kan. So dia bagi information, okay, that can be changed into molar mass. Okay, alright. So this is what we have so far. Okay, dia bagi one molecule is equal to this mass. Okay, so this can be used as our conversion factor. Okay, remember kita nak molar mass. Molar mass means mass for 1 mole. Okay, mass of the substance for 1 mole. So we could use here, okay, anything that represent 1 mole. Okay, so kita nak letak unit apa dekat sini, it depends on this dekat bawah ni. That's why kita letak molecule. So what value represent 1 mole? So it should be Avogadro's number. Faham tak? Apa kita nak letak kat sini akan depend dekat sini. Betul? So bila dia okay, this would be your unit. And then what value that has molecule as the unit? So it is Avogadro's number, and the Avogadro's number is equal to 1 mole. It's for 1 mole. And kita nak look for the mass for 1 mole. So that's why we can use Avogadro's number. Okay, alright, so we have that, and then we divide these two, and then we have N is equal to 1. So empirical formula is the same as molecular formula. Okay, alright, good. Okay, maybe we can proceed with Shasha still. Okay, alright. So this is the second question. Okay, pretty much the same, but the mass is not given in terms of percent composition. Perasan tak? Dia straight away give in gram. Okay, alright. So we can calculate for both. And then proceed further. As you can see, dapat terus whole number. So we do not have to multiply with any factor. Okay, so this will be your empirical formula. Next, molecular formula. So information yang dia bagi dekat sini, this is the information given. 0.5 mole 0.5 mole of the isobutane has a mass of 28.5 gram. This is information given in the question. So this could also be our conversion factor. Okay, alright. Yep, this one. Okay, ni pakai ni pula. Pakai apa nama tu, pakai conventional pula. Okay, so we want to find the molar mass of a compound. Okay, so what Shasha did here, they did gram mole, and then you have gram divided by mole, okay, to get the gram per mole, the molar mass for one mole. Or if you are using the the dimensional analysis punya method, just now the information that we have just now, okay, kita ada 0.5 mole, the mass is equal to 28.5 gram. Okay, what we want is gram for one mole. Okay, alright. So kalau in this case, siapa duduk atas, siapa duduk bawah? Dia depends apa yang kita nak. Kalau yang kita nak tu, what we want is the gram ataupun the mass, then the gram should be at the top, 28.5 gram. Below should be 0.5 mole. Okay, dia boleh manipulate atas dengan bawah sebab dia depends on what we want and what is given to us. Okay, alright. So here should be mole, kan? Ni kena sama. So kita nak mass for 1 mole, kan? The molar mass stand for mass for 1 mole. So here should be 1 mole lah. Okay, so mole. Then we end up with the final 57 gram per mole. So the rest will proceed the same as what we have previously. Okay, we got, so this is a good, very good. Okay, cancel out, the ratio need to be cancelled out, and then we will have n without the unit. Okay, alright, so 4, okay, multiply the empirical formula with 4, and then we will have the molecular formula as C4H8. Alright, okay. Return this. Now let's have S20. Let's have Shazwan. Okay. 2.14. Oh, okay. Right, so we have another checkpoint for empirical formula. Okay, but this time around, it's not the same as what we have earlier. Okay, it's not as direct as what we have earlier. Okay, for this time, this type of question, the information is not given in the form of separate mass for each element present in the compound. Dia tak bagi dalam bentuk satu-satu. Instead, it is given in the form of molecule. Okay, so our job is to extract out the carbon and hydrogen or whatever lah that is in the compound. Okay, alright. So normally what we did in our lecture, we have carbon, hydrogen and oxygen as the component of the compound. But janganlah ingat, oh okay, soalan mesti tanya carbon, hydrogen and oxygen. Okay, not necessarily. What we want to introduce to you is the concept. Okay, if we have a sample and then we burn it and then we have product that is a mixture of the elements in the compound. So how do you extract out? Okay, so the component may be, in this case we have iron. Okay, we have iron, and then it may it can be other than carbon, hydrogen and oxygen. So janganlah expect that soalan mesti carbon, hydrogen and oxygen. Not necessarily. Okay, kita nak introduce the concept. Okay, so for this time around, dia ada iron dalam tu, and then we have carbon and hydrogen. So we are not looking for oxygen lah. Okay, so ada student dia dah set carbon, hydrogen and oxygen. Mesti cari carbon, hydrogen and oxygen. Okay, itu bahaya tu. So this is the amount of sample, and this is the original sample. Okay, alright. So this is the mass of carbon dioxide, and this is the mass of H2O. Right? Okay. So what is this? This is ni nak cari apa nama ni? Ni nak cari carbon, is it? Kalau based on dia punya answer dekat sini, okay. Dia nak cari carbon. So starting out, dia ada carbon dioxide divided by the molar mass. Okay, this is to find the mass. The mole of carbon dioxide. Okay, this step is to find the mole of carbon dioxide. So this one will be cancelled out, and then we will have mole as our unit. And next, kita tiba-tiba, okay, kat sini lah yang saya cakap tiba-tiba tu. Tiba-tiba nak kena bagi dengan 12 gram per mole. Tak ada relationship, tak ada apa, tak ada cakap apa-apa pun statement, tiba-tiba darab 12 gram per mole. Apa kena-mengena 12 gram per mole ni dengan carbon dioxide ni? Ini, this is the molar mass for carbon dioxide. Okay lah, understood, because we are talking about carbon dioxide, the mass of carbon dioxide. Okay, divided by the molar mass of carbon dioxide. Then suddenly we have molar mass of carbon. Apa relationship kat situ? Okay, kalau tak nak buat dimensional analysis pun, you kena tulis lah, kena style conventional lah. You kena introduce in 1 mole of carbon dioxide, there is 1 mole of carbon. Even though dia punya ratio to cancel out 1 juga, you still have to show that. Itulah chemistry-nya. Faham tak? Okay, you cannot just simply darab 12 macam tu. Apa? You ingat kita nak faham, ni faham sendiri. Okay, tolong do not do that. Okay, you have to include, even though the ratio is 1:1, you have to either write or you use dimensional analysis. Okay, so ini maksudnya kita panggil cut short. Untuk 1:1 ratio tu, there is mark for that. So Shazwan will lost his mark dekat situ, that part, sebab dia tak ada that introduction. But the final answer will be dia dapat award as markah lah, tapi dekat situ dia hilang. Okay, alright. Sebab satu kan ratio dia, so tak payahlah letak macam tu. Even dalam slide note pun saya notice they use the conventional method, but still they provide the statement that for 1 mole of carbon dioxide there is 1 mole of carbon, and therefore the mole is equal to mole of carbon. Macam tu. Okay, alright. So if we were to use this one to what is given to us, gram carbon dioxide. Okay, alright. So here should be gram carbon dioxide. So the molar mass of carbon dioxide. Okay, so up here we should have 1 mole of CO2. Okay, so we have the unit in mole already. Next, this is the part where we introduce the mole of carbon. Okay, so below here we should have carbon dioxide. So in 1 mole of carbon dioxide, we have 1 mole of carbon. So this conversion factor, tahu tak? 1 markah tau dekat situ. Okay, kalau you hilang dekat sini and then kat bawah hilang lagi, you total kan berapa you hilang markah kat situ. Okay, so cancel out and then kita akan okay. Carry further, we are looking for the mass kan. So bawah should be mole carbon. Okay, so 1 mole of carbon is equal to 12 gram of carbon. Cancel out again, 0.609 gram of carbon. Okay, alright. Same goes to hydrogen, gram hydrogen H. Sorry. Okay, alright. So ni divide. This is to find hydrogen. Okay, this is to find hydrogen. Okay, from H2O. So divide, and then suddenly 2 mole H2O. Datang dari mana 2 mole H2O ni? Just what? Where did this come from? Oh, Syazwan. Is Syazwan there?
Sekejap, nak tengok soalan.
Nak tengok soalan. Saya tengah discuss ni soalannya.
Kok gini? Jom. Entahlah madam, saya pun tak ingat.
Entahlah pula. Kentut korang betul ada pula tak tahu, siap tak tahu That's why lah. That is the problem. Okay. When you are saya nak promo habis kan. Ini nak pulang apa tu masa peribahasa tu. Apa benda saya buat? Pulang paku buah sepih. Apa tu? Apa benda? Itulah yang saya nak cakap tu kan. You nak pakai conventional method. Can you buat betul-betul conventional method tu, buat proper way. Dia tak nak pakai dimensional analysis kan. Buat, tunjukkan saya, bukti saya sekarang. That your method ni, your conventional method is better than the dimensional analysis punya method. Okay, so far saya cakap, kecuali tadi siapa the closest tadi, yang the first one just now, yang include the unit tadi. Yang tu yang paling closest lah. So far yang saya check, go through the checkpoint, go through the tutorial, guna conventional method, mesti tertinggal unit, confirm. Okay, mesti ada dia tertinggal unit sebab dia dah biasa the method tu, dia just darab bahagi macam tu saja. So far. Inilah masalahnya. Okay, so it shouldn't be 2 mole of H2O. Okay, dia nak highlightkan 2 mole of hydrogen atom in the molecule tu, in H2O, 2 mole of hydrogen atom. Okay, and then tiba-tiba dah lah 2 mole of H2O, tiba-tiba 1 gram per mole. Datang dari mana? Maksudnya ini gram of the mass for hydrogen kan? Tapi kenapa tiba-tiba mass of hydrogen, then suddenly here H2O and then hydrogen? Apa dia punya relationship there? Okay, you are not presenting your answer tu properly tau. So dia tak deliver. Okay, unfortunately, so 0.457 gram H2O. So here should be the molar mass kan, 18. So up here should be 1 mole of H2O. Okay, alright. So down here we have mole of H2O. So this is the time we introduce the number of hydrogen. Okay, so we have 1 mole of H2O. Then there should be 2 mole of hydrogen atom. Jangan cakap H2 pula. Bukan H2. H2 tu maksudnya gas tau. Ini dalam H2O there are 2 hydrogen atoms. So it should be H only. Okay, alright. So proceed further. So up here we should have mole hydrogen atom kan. Alright, so the mass of the hydrogen atom. So here should be 1 mole, up here should be 1 gram hydrogen atom. 1 gram. So this is the molar mass. 1 mole is equal to 1 gram of hydrogen. So cancel out, zap, dapat the final answer. 0.5078 gram. Okay, so we can simply minus the value that we have calculated just now. So total up the carbon and the hydrogen, okay, for us to find out the mass of our ion. So once we have that already, so we can simply find out the empirical formula. So that will be your final answer. Okay, right. Okay, all right. Next would be let's have Izzat. Checkpoint. Okay, next will be limiting reactant kan. Okay, check point 15. Question 1, okay. A 5 gram of sodium reacted with 5 gram of oxygen produce 5.38 gram sodium oxide Na2O. Calculate the theoretical yield. Okay, so given are the values for sodium, which is the reactant, and oxygen, okay, which also the reactant. And what is this value stand for, guys? This is value for,
Actual yield.
yeah, okay, that is the value for actual yield. So sodium oxide is our product, okay. So you have to identify that first, because kalau you do not know what this value represent for, then you might have problem, okay, when you are trying to calculate for the percent yield or theoretical yield, okay. You akan confused, oh ni value apa ni, okay, alright. Calculate the theoretical yield. Okay. In order, yes, question? Okay, we get the switch on the mic. Okay, theoretical yield. In order to know the theoretical yield, we have to know the limiting reactant first. Okay, we have to know the limiting reactant first, because yield, okay, the amount of product form will depends on the limiting reactant. So we have to determine that first. Okay, misi mencari limiting reactant. Okay, we have to check for sodium. So this is for sodium and this is for oxygen. Okay, right. But before that, make sure that you have your, what do we call this? Balance equation. Okay, as you can see, there's no balance equation given, tapi dia pun tak suruh awak buat the balance equation. Is it? Ataupun dia dah include?
Tak suruh.
Tak suruh Okay, it's not given Right, so that means you have to prepare the balance equation then. Okay, limiting reactant, this one. Okay, it's not given. So even though dia tak suruh pun, tapi you should know lah. You should have your balance equation. Okay, if not, macam mana you want to have the stoichiometry for the product and reactant. Alright, so okay, good. Okay, good. Izzat is using dimensional analysis. Okay, alright. So as you can see, we have this 2 mole sodium will produce 1 mole of sodium. Okay, ini okay. Kita tengah cakap sodium kan, ni kan. Alright, okay. Oh, dia dah kecilkan siap-siap dah ni 4 dengan 2. Okay. So tak apa, kalau nak tulis kat sini pun tak apa. 4 dengan 4 and 2 ni. Doesn't matter because nanti kan dia after all it is a ratio kan. So 2 and 1. Okay. Alright, so here is 2, 1. Then kalau macam tu, kenapa tak terus sini 2, sini 1 kan? Betul tak? Check. Oh, tak boleh. Tak boleh. Apa ni madam? Ajaran sesat ni. Sebab dia kena consider the oxygen. Okay, betul lah tu. Tapi sebab dia apa simplify here, okay? Dia simplify dekat sini. Alright. So kita selesaikan. This is the mole for the mole of the product can be produced from sodium, and then we have oxygen. Proceed the same way. So 1 mole of oxygen will produce. Betul ke ni? N2O kan? Ni macam tak betul je ni. This is 1 kan? 1 to 2 lah kan? Betul tak guys?
Betul.
Macam mana jadi 1 ni? Itulah nanti confuse. Jangan ubah lah. Ambil as is lah. Jangan try to kecil. I assume you are trying to simplify lah because this is 2 and this is 4. Okay, kita simplify kan and then we can have that. So that is unnecessary. But obviously from here salah lah ni. Okay, the ratio should be 1 mole of oxygen will produce 2 mole of sodium oxide. So if you salah kat sini, you better lah berdoa Walaupun salah kat sini, still limiting reactant tu, you still dapat betul. Okay. So oxygen gas so it should be 32, not oxygen atom. So oxygen gas because it is O2. Okay, cancel out. This should be great. Oxygen. So how about the mole? Is it correct, guys? (0.3125) see? 0.3125 mole Na2O. Nasib baik. Tapi dia still salah kat sini lah. Okay, Izzat will be the mark here will be deducted. So because it should be 0.3125. Okay, next step we have to compare between these two which one is the least number. Okay, nasib baik lah. Either this ataupun jawapan dia yang salah tu still besar value dia than this one. So somehow Izzat can still get the same limiting reactant. Okay, alright, so which is sodium. Okay, because based on the value, sodium can only produce this amount of sodium oxide. Okay, alright, so the answer will be sodium. Okay, bukan nak itu jawapannya. Ingat soalan nak theoretical yield. So theoretical yield, we will choose the least product that can be formed, which is from sodium just now lah. Okay, alright, so this one multiply with the molar mass to get the mass of the product. So this is the mass of the product. Okay, and this is also what we call theoretical yield. Okay, right, good. Moving on, the mass of excess reactant left over. Okay, mole of oxygen present. Okay, so automatically we will know that oxygen is the excess reactant. Automatically, once we have determined the limiting reactant, automatically oxygen is the excess reactant. So if we want to know the leftover, okay, we should know the mass needed, the mass of excess reactant needed, okay, in order to react with the limiting reactant to produce product. Nak tahu leftover, kita kena tahu berapa kita pakai, baru kita boleh tolak kan later on. Okay, alright, so we know the excess reactant just now. Okay. Okay, good. So this is the mole of oxygen, the original, okay, provided in the question. Maksudnya dalam reaction tu, kita sediakan sebanyak 5 gram ataupun 0.1563 mole of oxygen gas. Okay, this is excess lah because we have determined that just now. Okay, we have determined that just now. So we want to know out of this value how much has been used, okay, to produce product. Okay, alright. So in order to know how much has been used, we have to use the limiting reactant as our reference. So reference, limiting reactant is the reference. Okay, in order to know the amount of product and in order to know the amount of excess reactant left over. Okay, alright. So macam mana ni? Ini pelik-pelik ni kan, guna number-number yang macam gini, dia agak bahayalah sebab you guys may not familiar with the value. Okay, alright. So dekat sini dia dah times 4 mole. At the end of the day dia cancel out juga dekat sini. Okay, alright. So I do not prefer this method. Kenapa dia pakai 4 mole? Because based on the ni because based on the balance equation tu, dia based on the balance equation. Okay, so 5 gram of sodium convert jadi sodium berapa? 23 gram kan sodium kan. So this is 1 mole. Okay, alright. So this is the part kita introduce the excess reactant and limiting reactant. Okay, so this is for sodium Okay, so mole sodium. So from the balance equation, that we need 4 mole of sodium to be reacted with 1 mole of oxygen gas. Ini je yang kita nak pun. Okay, alright. So mole sodium cancel out, gram sodium cancel, and then we will have the same because 4 akan cancel juga kan. This is based on balance equation. Okay, justification untuk Izzat buat macam ni adalah this is from balance equation, and this is the amount for 4 mole of sodium. Okay, 4 mole of sodium, and this is the mass for 4 mole of sodium tadi. Nampak tak? Tu dia buat macam tu. Tapi that is very uncommon lah. Kalau you are aware of what you are doing, then go ahead buat. Tapi saya tak prefer cara macam ni. Okay, sebab ini dia akan berubah-ubah setiap kali, depends on the question. So let's just stick with what we are familiar with. Okay, cara macam ni lah. Ini daripada balance equation. This is where the part where we change to mole, from gram to mole. This is the stoichiometry from the balance equation. Okay, alright, so we have that which is equal to 0.05435, is it? Yeah. Betul ke? 0.05435, and then kita minuskan. This is the initial and this is what the reaction needs. Okay, so tolakkan and then we want the mass. Okay, times with gram per mole. So ni tiba-tiba 32 terkontang-kanting kat situ kan. Kenapa kan? So tolak and then we can find out the mass. Okay, using dimensional analysis. Okay. We have more question. Oh, ada percent yield. Okay, percent yield 5.38 gram over this one is the total the given value. This is the theoretical. Okay, this is it the correct value, guys?
Yes.
Yes, 5.38 divided by 6.74. Okay, 5.38 divided by 6.74 times 100. Okay, this is actual is given, and then this is theoretical that you have calculated just now. So the percentage yield is equal to 79.83. Okay, right. Okay, dah ke?
Madam,
Ya.
I have a question.
Yes.
Yang untuk equation tu kan madam, saya buat Na tambah 2Na tambah oksigen, natrium 2 oksigen. Maksudnya oksigen tu saya tak buat molekul, saya buat oksigen je.
Oh, tak boleh.
Sebab saya macam dia kata soalan oksigen bukan oksigen gas. Tapi kalau saya buat macam tu pun dapat markah sama.
Sekejap. Sebab apa?
Is it valid?
Sebab dia balance kan. Sebab kat sini you still what's the coefficient here? 2O, is it?
Macam Na tambah O, 2Na tambah O.
2Na tambah O and then Na2O.
2O.
And then this one mole. Okay, no wonder lah you still get the same answers, but because the ratio is the same as what we have here. Okay? Tapi kita bukan nakkan jawapan akhir saja. Faham? We want your answer, the working solution is throughout tu betul. Okay? Alright. So from the question, even though they tak mention oxygen gas, but it is understood this is a reaction. Okay? Oxygen present in this world normally in the form of O2. It is very rare for the oxygen to be dalam keadaan dia punya single state, which is O alone. Nak cakap O atom. O atom. Okay, they're very rare unless you have you conduct a very extreme condition of reaction. Tapi bukan normally, memang dia naturally exists as O2. Okay, and after all this is a reaction that is conducted normally at room temperature lah kan. So oxygen gas lah, it should be oxygen gas. Even though it is not mentioned there, it's not mentioned there, oxygen gas. Faham tak? Oxygen dia takkan stand alone O macam tu. Dia mesti sama ada dia combine dengan orang, N2O ataupun dia CO2, CO, dia mesti combine with someone lah. cannot be present as O single atom macam tu. So by right the understanding ataupun the concept there is wrong, salah dekat situ. Okay, but you of course the mark will be deducted, tapi kita still consider lah the final answer and whatnot. But here maybe your equation will be wrong. Okay, so akan kena tolak juga dekat situ. Okay.
Okay, thank you madam.
Alright, so that's one thing. We are not only concerned on the final answer, okay, we are concerned on the whole throughout you punya process tu. Okay, alright, I think kita ada one more question kan. Maybe you can check your own answer with the atom economy kan. So this will be your final answer, guys. The final answer for checkpoint 16. Okay, please check. Okay, this is I can consider it as a very straightforward question. So kebetulan dia 1-to-1 kan. Please take note on the coefficient. Okay. Alright. Okay. So that's all for the checkpoint. Okay. So there you go. Our 1 hour and 15 minutes. Okay, for that discussion alone. Hope you guys benefit from that. Okay, so let's have another 3 minutes. Let's have 3 minutes rest. Okay, before we proceed for our next subtopic. Okay.
Madam nak tanya.
Yep.
Contoh ada soalan minta theoretical yield. Contoh soalan tu dia bagi iron 3 oxide react with excess carbon monoxide, macam tu. Daripada statement tu maksudnya carbon monoxide tu dah excess reactant kan?
Yes.
So terus guna iron 3 oxide untuk cari theoretical yield.
Yes.
Okay, thank you.
Okay, so it depends on the type of question. That is the most scariest part lah. If that's the case, like what your friends mentioned just now, it is already stated in the question. Okay, this substance has been reacted with an excess of substance ataupun compound. That means dia dah highlight the excess reactant. So automatically the other reactant should be the limiting reactant. Okay, and the rest of your calculation should be based on the limiting reactant. Okay. So itu soalan dia akan tackle kat tempat lain pula yang akan agak mencabar sikit lah. Okay.
By the way madam, saya tak faham sangat part yang ijat punya jawapan tu, yang madam kata tak nak buat dekat bawah yang nombor unfamiliar tu, yang 4 mol.
This one?
Saya tak faham. So cara yang madam nak macam mana?
This one? Ni. This one, this is the alternative to Izzat answers. Okay? So we have 5 gram. Okay, you should know, okay, for each conversion factor, you should know why do we use this conversion factor. Okay, the reason why we use this conversion factor is we want to convert the gram into mole. Ni conversion factor ni. Dia diperlukan untuk kita convert from gram to mole. Okay, so Izzat can also Izzat method here, okay, can also find mole. Tapi we are using 4 mole and 92 gram. Okay, 92 gram. So this approach is not, saya boleh pakai, tak salah, boleh pakai. Sebab you are actually referring to the mana nak naik balik? This equation. Okay? Kalau based on apa yang saya buat dekat sini, this is the step to find mole. Next stoichiometry.
Okay, I see. Dah faham.
Ni tak perlu pun 4 mole ni, because at the end of the day dia cancel kat sini tau. 4 mole. Yang tinggal hanyalah ini 92 ni. Dia sebenarnya dia 4 times 23. 4 times 23 guys tu. Okay, you got 92 guys tu. So why not you use this method rather than you use this method, because this is more I don't know, saya rasa friendlier lah. Okay, rather than you have to change the mass daripada balance equation just now, okay, kepada 4 mole, and then ni you have to times it with 4, the mass tu kena times with 4. 23 times 4 pula, 92. So that you can tally kan, dekat atas ni dengan kat bawah, so that you kena tally. Betul ni, relationship ni betul. This is 4 mole and the mass for 4 mole of sodium is equal to 92. Betul, that is correct. And this is from the balance equation. Betul, tak ada masalah, betul. Cuma at the end of the day, dia friendly tak kepada you? Friendly maksudnya boleh create tak balik the answer. Okay?
Okay. Thank you, madam.
Okay. Okay guys, are you ready?
Yes.
Oh, so excited Okay, good, very good. Okay. So let's carry on with our lecture. Okay, 1.9. Bismillahirrahmanirrahim. Concentration expression. Okay, so how do we express concentration? So we have one learning objective for this subtopic. Okay, so make sure that at the end of this subtopic, you should be able to calculate the concentration of solution involving, okay, normally we use molarity, okay, to represent our concentration, but other than molarity, we also have percent by mass, okay, to describe our solution. And we could also use percent by volume and molality and mole fraction. Okay, so I was told previously that you are not familiar with molality. Okay, you haven't learned this during your SPM time. Okay, so these two might be new to you. Okay, but this one what I can consider as common. Okay, molarity, percent by mass is almost the same as what we have in empirical formula. Okay, and we also have percent by volume. Okay, let's move on. Okay, solution. Okay, so concentration expression is used for solution. So for solution, we have two main components, okay, which are solute and solvent. So what is the definition of solution? So in short, we could represent solution as a homogeneous mixture. It is a mixture. Why is it a mixture? Because it is a combination of solute and solvent. Okay, all right, so homogeneous is like the properties of the mixture. is it heterogeneous or is it homogeneous? Okay, homogeneous means at the end of the mixing, okay, you masukkan, you mix kan, at the end of the mixing you will observe a homogeneous mixture, one phase. Okay, homogeneous, homo means same, okay, one phase of solution. Then only it is called solution lah. Okay, take for example, we have a beaker of water and then we add in this solute. Okay, this solute is iodine. So when we mix these two, it will produce this solution. So as you can see, we can only observe one phase of a solution. Okay, so this is what we call homogeneous. So solute is the substance that present in small amount, dia ada sikit, but solvent on the other hand, it is present in large amount. This is small amount and this is large amount. Okay, all right, yeah. Okay, so when this solute is added, okay, when this solute is added, this is microscopic view of how the solution takes place. Maksudnya macam mana how the solution is formed. So when the solute is added into the solvent, okay, and then this solute and solvent, there is attraction among them. Ada attraction between them, okay, and then this clump of solute will be pulled out, dia akan ditarik, okay, sebab ada attraction tadi kan, it will be pulled out and then somehow later on it will be dispersed throughout the solution lah. So this is what I meant by dispersed just now, okay. Okay, so solution concentration. So how do we describe? Okay, so we have that solution. So how do we describe the presence of solute and solvent? Okay, the presence of solute and solvent in a solution. So we call it as concentration. Okay, that's the term that we use to describe to describe a solution lah. Okay, so we have so many types of expression. Expression means how do we describe the solution in a form of concentration lah. So concentration is actually the ratio of the amount of solute to the volume of solution. Okay, all right. So normally we use molarity as M capital. So the formula for molarity is equal to mole of apa sebenarnya? Mole of solute divide by volume in liter of solution. It should be solution, okay, not solvent. Okay, we know that solution means solute plus solvent. Okay, because later on we have molality. Okay, molality it will use solvent. Okay, later on kita tengok. Okay. Okay, that will be it. So it should be in liter of solution. Then only it is a molarity. If it's in milliliter, that means it's not molarity. Okay, all right. So the unit can also be written as mole over liter. Okay, it's actually the same as molarity. So this is in short, and this is based on the formula. Okay, mole of solute per liter of solution. That means for 1 liter of solution, there is, for example, 0.5 mole of solute. Okay, alright. So if we use this, that means kita tak berapa nampak what is the relationship of solute and the solution. But if we are using this one, then kita boleh describe the solution. Okay. This is just to highlight lah, mole per liter is actually the same thing as molar. But this one kita ada extra information there. Okay, kalau saya dah biasa, saya memang understood, okay, for molarity is actually equal to mole per liter. That means for 1 liter there is this much of mole of the solute. Okay, alright, so concentration of a solute is represented as square bracket. Okay. sebab nak tulis concentration, so it can be a hassle there because we don't have time to write this much of word ataupun alphabet banyak dekat situ, so we can use symbol as our concentration. So we use square bracket. Okay, so katakanlah X ataupun concentration of sodium chloride in solution kan, so we may use this square bracket. Okay, alright, remember it should be in liter. It should be in liter. The volume need to be in liter. Okay, so we may use this apparatus as our when we are dealing with solution. Okay, we have measuring cylinder, we have conical flask, we have beaker, big beaker, small beaker, and we may have a volumetric flask and so on. Okay. Alright, so maybe boleh tambah dekat atas tu, the title here is dilution. Tambah dekat atas, dekat tajuk tu, okay, is dilution. So in a dilution, the number of mole of solute does not change, only the volume of, okay, this is a typo. Okay guys, please take note, it should not be solute, it should be the volume of solution. Yes, the volume of solution. Okay, kadang-kadang saya tak perasan typo-typo macam ni, please let me know. Okay, sebab saya explain balik, that's why saya tak notice the typo, but you guys need to know this typo because takut it may affect you. Okay, masa you punya revision and then you have different false definition lah. Okay, alright, so this is for dilution. Dilution means pencairan. Okay, so initially, okay, let's have example. So initially, this is the solution lah. Okay, this is the solution. So as you can see, the volume of the solution is lower ataupun smaller than this is before. Okay, and then after we add in solvent into the same solution that we have here. Okay, as you can see, the solution volume is now increased, higher volume. Okay, but what we want to highlight here is the amount of solute present in the beaker, in the solution. Okay, initially katakanlah we have 0.5 mole of solute. Okay, in this before beaker. And then when we add in the solvent into the same beaker, okay, will it change the number of solute present, guys?
No.
Okay. So initially we have 0.5 mole of solute in here, but when we add in solvent, it will not change the number of solute, the number of mole of solute present. What changed is that the total number of the total volume of the solution. That one they change, but not the number of solute. Like you imagine you nak buat air sirap lah, for example kan. Okay, you add in 2 spoons of sugar. Okay, in your that is considered quite a lot in your mug ke. Okay. So you tak dua spoon of sugar and then you taste it and then you feel, oh, this is so sweet. Okay, this is too sweet. Then you, what next? Okay, you add in water lah kan, because it's too sweet. So when you add in water, will it change the 2 spoons of sugar in the mug already? Tak ada kan, dia tak berubah kan. Yang berubah is the amount of the volume of your solution ataupun the volume of water and solution. But the number of solute will not change. Provided you janganlah pergi tambah gula lagi. Kalau you tambah gula, of course lah, it will change the number of solute. Okay, alright. So from there, from that understanding, we could say that the mole of the before ataupun the mole of the initial solution is the same as the mole in the final solution. Okay, from that understanding, so we could say N1 is equal to N2, N initial is equal to N after or whatsoever. Okay, alright, so to N, okay, N is also equal to M1 V1 is equal to M2 V2. Okay, M2 V2. V2. So this represent dilution. Okay, don't get confused with what is that? Acid base later on. Okay, normally to use acid base we use MAVA, MBVB, not M1V1, because walaupun dia sama, dia punya styling dia tu almost the same. But let's just separate them lah. Okay, dilution, let's go for M1V1, M2V2. Okay, but for acid base later on, you may use MAVA, MBVB. Okay, alright. Okay, so stoichiometry relationship. So we cannot run from stoichiometry when we are dealing with chemistry. There will always be stoichiometry, even though it is in a solution form. Okay, in solid state ataupun in gas, we still can't run away from stoichiometry. Mesti ada stoichiometry regardless. Cuma dia punya phase je berbeza. Okay, alright. In order to have stoichiometry, the basic representation of stoichiometry is by having balanced equation. Okay, alright. So let's consider this ionic compound. So ionic compound dissociate into their constituents ions when dissolved in water. Okay, this is a balanced equation. So calcium bromide is in solid form. When it is dissolved in water, it will dissociate into its constituents. So the constituents of calcium bromide is calcium 2+ and bromide, right? Okay, so we balance this out. We have two coefficient of 2, okay, for bromide ion. Okay, take for example, we have 0.10 molar of calcium bromide, okay. So this one will be dissolved later, dia akan jadi aqueous, okay, dalam water. Okay, so let's say 0.10 molar calcium bromide. So how do we relate the constituents ataupun the ions with the substance itself? So that means the concentration, okay, based on the equation that we have here, in 0.10 molar of calcium bromide, the concentration of calcium 2+ will also be 0.1 molar. Okay, and the concentration of bromide ion, as you can see, we have coefficient 2 dekat bromide kan, so we have to multiply with 2. Okay, so this is in a form of compound. This is in a form of once it has separated, okay, so dia akan present in ionic form. Itu saja. Okay, so this is the relationship that we have. Okay, right. So far, any question, guys? Before we proceed to another expression of concentration, ada question?
No.
Okay, so far so good Okay, dia simple je. Kalau based on slides, concentration ni macam senang. Tapi the critical part is the question. Okay, we will look into example later on. So dekat situ, macam dia agak tricky. Okay, so another expression of concentration. Just now, okay, what we have earlier is called molarity. Molarity can also be used to describe concentration. So other type of concentration, it can be expressed in a form of mass percent. So in total we have 6 of them. Okay, so A, B, C, then we have D, E, including the molarity just now, the earlier one. So in total we have 6 of concentration expression. Okay, all right. So let's go one by one. Okay, mass percent from the term itself. Okay, mass is mass lah. Percent, that means in 100%. Okay, all right. So to calculate the mass percent of a solution, we need to consider the solute, of course. Remember, concentration is used to describe a solution. Okay, we know that in the solution we have solute and solvent. Okay, in combination, these two we have solution. Okay. Alright, so to know the mass percent of solute, so what we can do is mass of the solute divided by mass of the solution times 100. Okay, alright, so please take note that mass of solute plus mass of solvent will be equal to mass of solution. Okay, only mass can be total up to get the mass of solution. Okay, maybe we can refer apa B ni, cuba tengok B. Volume percent maksudnya in a form of volume lah. Just now we have mass percent kan. Okay, for volume percent, it's actually the same as what we have for mass percent, but it's in volume. Okay, it is in volume. Volume of solute divided by volume of solution times 100. Okay, please take note on this. But for volume, we cannot just simply total up solute plus volume of solvent to get the volume of solution. We cannot do that. Okay, tak boleh. It can only be applicable for mass sahaja. We can total up to get the mass of solution, but not for volume. Okay, because we know that volume is sensitive to what we call that, temperature. Okay, it can expand. When it expand, it consumes space. Okay, when it shrink, okay, dia ada more extra, dia ada extra space there. And then that means it keeps changing now. Bila dia change dekat situ, we cannot just simply total up the volume to get the total volume. Okay, total volume of the solution. It's not the same. It's not the same unless you measure it. Okay, you measure the volume at that time, at that temperature. Then kita represent the volume that you measured to is for that particular temperature, at that temperature. Okay, so that would be, yalah, take note, jangan main simply tambah saja. Only for mass je kita boleh tambah. Okay, dekat sini, okay, contoh soalan contoh representation of expression for mass percent. Soalan boleh bagi dalam bentuk macam ni. Okay, look at this. So 12% weight per weight. Weight maksudnya for mass lah. Okay, 12% weight per weight sugar solution. What does this mean? Apa maksud dia dekat sini? Okay, it means that there is 12 gram of sugar. Okay, because we are talking about sugar kan. So sugar is the solute. So sugar is the solute. Okay, alright. So per 100 gram of solution. Okay, per 100 gram of solution. So there is 12 gram of solute in 100 gram of solution. Faham? Itu dia punya apa nama tu, dia punya description lah. That will be the description of this 12% weight per weight of sugar solution. Okay, so ada hidden information dekat situ. If I were to ask what is the mass of solvent, so how do you find the mass of solvent, guys? What would be the mass of solvent from this statement that we have here?
Solution tolak solute.
So what's the value?
88.
Yes. So to get the mass of solution, okay, to get the mass of solvent, we know that mass of solution is equal to mass solute plus mass solvent. So we have this already, right? 100 gram, and then we have this 12 gram. So we can find out the mass of solvent. So we simply minus these two, we get 88 gram of solvent. That is the hidden information, guys. Tu you sendiri kena tahulah. Okay, tak semua benda kita akan give information. So like we have here. Okay, you should know that what does it mean by 12 weight per weight sugar solution? That means there are 12 gram of sugar in 100 gram of solution. And we can also find out the mass of the solvent. Okay, this is only applicable for mass percent, but not for volume percent. We cannot do this, cannot. Okay, all right. So if this is the kind of information when it involves volume percent. 22% volume per volume ethanol solution. So what does this mean? So it means that the solution has 22 ml of ethanol. So ethanol will be our solute. Okay, in 100 ml of solution. okay, in 100 ml of solution. Same goes to, it can be a mixture of mass and volume. Okay, percent mass per volume. That means mass of solute divided by mass, the volume of solution. Okay, times 100. Again, dia tak boleh involve volume. You cannot simply say that these two, when we total up these two, we get the total volume of the solution. No. Okay, all right. So how do you describe this information in percent mass per volume? 32% weight per volume sugar solution. That means there are 32 grams of sugar, which is a solute, in 100 ml of solution, because we are talking about volume. Okay, guys? So it should be 100 ml of solution. Okay, right. Molality. This is the one that is maybe new to you guys. Okay, so earlier on we have molarity. Okay, sekejap ya guys. I need to okay, sorry for the interruption just now. Okay, let's continue. Where were we? Molality kan? Okay. So this is a molality. So earlier on we have molarity, R-I-T-Y. Okay, and then here we have molality. It may sound the same, but it's actually different. Okay, molality. Okay, so what is the definition of molality? Okay, it is a okay. Let's just look at the formula. Okay, molality, or we can use small letter m. Molarity just now we have capital letter kan for m, and this one molality is small letter m. Okay, mole of solute. Okay, this is the same as molarity just now, but look at here. Okay, it's not volume, but it is mass. And the mass need to be in kilogram, bukan gram, kilogram. And then of solvent, not solution. Okay, so please recall balik molarity tadi. What's the formula for molarity? Mole of solute divided by volume of solution in liter, but for molality, it's kilogram of solvent, not solution. Okay, all right. So alternative, this is the unit, or you can also use this as our unit, mole over kg. Okay, so it is understood that if you have the value, katakanlah 0.5 molal. In short, it is called molal. M-O-L-A-L, molal. Okay, kalau molarity, it is called molar. This one is called molal. Okay, so in 0.5 molal, okay, if we are using this per unit, kita tak nampak kan? But if we are using this, that means we can describe molality as there is in 1 kilogram of solvent, there is 0.5 mole of solute. Okay, based on what we have for the what we call that formula. And also guys, this could also be our conversion factors, but dia ada atas dan bawah. Okay, right. Last but not least is mole fraction. So mole fraction can be represented as x, tapi dia bukan normal x, dia macam ni. Okay, mole fraction A, for example. So what is mole fraction? Fraction of mole. Okay, the mole fraction is the fraction of the mole of one component in the total moles of all the components of the solution. Okay, take for example, we have a beaker of solution. Okay, in the solution, we may have more than one solute. Siapa kata dalam solution mesti ada one solute saja? Not necessarily, Okay, alright. So we may have more than one solute. Katalah we have solute A, solute B, solute C, and solvent also is in the solution. Okay, alright. So the question is asking for mole fraction of A. Mole fraction of A. So how do you calculate mole fraction of A? Fraction of A daripada the whole solution. That is what it meant by mole fraction. Now, okay, alright. So this is how you write, ataupun you can use XA. Okay, is equal to mole of the solute for A. Untuk A ni kena tambah ni, mole of solute A divided by total moles in solution. Okay, divided by total moles in solution. Let's say for example we have A kan, we have A, B, C, and then we have solvent also. Don't forget that we have solvent in the solution. So we have to total up all the moles that are present in the solution. So that's why the total mole in solution. Okay, alright. So this is only for A. If the question is asking for B, that means you have to calculate for B lah. B, that mole of B solute divided by total mole. Alah, mole fraction maksudnya per part lah, parts. Okay, dia macam like for example kan, I want to know how many of female student in S20 for example, and how many students are boys from S20. Okay, take for example we have 10 girls and 20 boys in S20. So when we total these two, kita akan dapat 30 kan, 30 students. Okay, so this would be our total student lah. Okay, so kalau saya nak tahu fraction of girl student in S20, that means macam mana saya nak buat fraction? So 10 over 30 lah. Okay, cuma this time around the unit will be students. Okay, so how do you get 30? 20 plus 10 kan? So as you can see, you total up the component of S20, which is boys and girls. You got 30, okay, students. So same goes to the solution, okay. But the unit used is small, not lah, bukan student lah kan? Okay, so that will be mole fraction, okay. Okay. Any questions so far, guys? Before we go for example, okay, kita try tengok example and then you try to do it later and then we'll discuss it, okay? Alright, cuba tengok Okay, kita dah tahu dah all the definition, all the formulas for all the expression as of now lah. For our level, we can only cover for 6 expressions saja. We can have more In fact, we have more than 6 in chemistry. Okay, at the end of the day, it depends on what measurement, what measurement that we use for the solution to describe the solution. Okay. Contoh soalan. Calculate the volume of 10.5% by mass soda contains 78.5 gram of sugar. So what does this mean? Apa maksud 10.5% by mass soda? Okay, so how do you express ataupun how do you describe the term given here by mass soda? So this is the information given tau. Ni soalan sebelum dia nak tanya, dia kena bagi information. So these are the information and this is the question. Soalan tanya, for 78.5 gram of sugar, what is the volume? What is the volume for soda? So soda tu apa? Soda tu solution ke ataupun solute? Soda tu solution ke solute, guys?
Solution. Solution.
You don't expect, maksudnya don't simply expect that the question must ask in the form of solute and solvent ataupun and solution. Not necessarily. This is what we call application. Okay, so you should know what is the solute and what is the solution. Okay, alright, so 10.5%. So the soda is the solution. So sugar is the solute. So 10.5% means by mass of soda, okay, weight per weight lah. This is what we call weight per weight percent. This is important because we want to know whether it is in volume or weight. Okay, then okay, so the description would be there is 10.5 gram. If we need to convert this into gram, then it will be 10.5 gram of sugar. Sugar is the solute. Okay, solute in sebab we are talking about percentage kan, that means in 100 part lah, percent 100% kan, so in 100 gram of soda lah. Soda in our case is solution. Can we find the mass of solvent? Yes, we can. Okay, we can simply minus, this is just to describe apa information, hidden information that we can get from the value here. So to get the mass of solvent, it would be mass of solvent is equal to 100 gram minus 10.5 gram. Okay, so berapa jawapan ni? Kiralah sendiri ya. Okay, so 5.9 kan? Is it? Berapa ya? Salah.
89.5.
89.5 gram. Okay, thank you. So this will be the mass of solvent, water ke apa kan? Dia tak apa, kita letak je sebagai solvent. Okay, alright. So soalan tanya sekarang. So this is the information which we can use as our conversion factor. Sebab kita ada dua information, see? So for 10.5 gram of sugar, okay, the total solution would be 100 gram of soda. How about if we have 78.5 gram of sugar? So what will be the mass of soda, guys? We could use the conversion factor kan? We could use the conversion factor. But the question is asking for volume, not mass. So ada extra step dekat situ. So that is why the density is given. Okay, if not, how do we convert the mass to gram, the mass to mil? So extra information need to be given and the density is given. We know that density is mass of solution, okay, divided by volume of solution. That's why we have it in gram per mil. For 1 mil, the mass is equal to 1.04 gram. So that is what it meant by this gram per mil ni. This is the explanation. Okay, alright. So this is to convert into volume. Okay, so apa yang kita ada information yang dibagi tu kita guna dekat sini. Okay, alright. So this is the part yang kita nak relate. So this is the solute kan. Sugar can be cancelled out. This is solution ataupun we can call it as soda. Okay, 100 gram of soda. So ini kita dah dapat dah soda sebab dia nak tanya soda kan, dia nak tanya soda mass. But what we want is volume kan. So that's why we need to have this extra step here. This is solution dia in short. So we have gram and then up here we have mil. Okay, so this one will be cancelled out. This is also soda. Dia bila tak tulis tu kita tak tahulah siapa punya. So soda cancel out. We have this as our volume. Okay, nampak tak dia agak scary sikit concentration ni. And then concentration solution can also be applied for our limiting reactant ya. Jangan ingat dia mesti involve solid saja, not necessarily. Okay, it can be in the form of solution because at the end of the day what we want is the mole kan. Regardless lah dia solution ke dia solid ke, doesn't matter. What we want is the mole, because we need the mole to compare, to relate the stoichiometry part. So regardless lah dia solution ke mass, dia apa nama tu, solid. Okay, alright, I think that's all for now. Okay, we have example, a lot of example and checkpoints. Okay, so try to do it on your own based on what you have understood from our lecture. Okay, alright, so that's all. Any question, guys?